Welcome everyone to Knox Game Design for September 2025. My name is Levi Smith. So this month's topic is special weapons. I'll be talking about how to create 10 special weapons in a 2D platformer game. So the first weapon I'll talk about is like a normal, what they call a buster weapon, basically just shooting forward. See this in a lot of classic 8-bit games. So whenever the player presses shoot, basically you're going to determine which way the player is facing, either in the positive X direction or the negative X direction, and then use that to set the initial velocity of the projectile. Whenever the projectile is spawned, then we're going to set the position to the player's X, or X plus the width if they're shooting to the right. And then the Y is going to be the player's Y plus an offset. And then the velocity is basically going to be the speed of the projectile times the ways the player is facing. On update, the X position, we're going to assign to that the velocity of X times delta time. Delta time is basically the time between frames. Most game frameworks and development environments have a concept of a delta time or a way to calculate it yourself. The demonstrations I'll be doing are in MonoGame, but you could do this in Unity. It has a delta time as well. We also want to keep track of the lifetime of the projectile. So on each update, we're going to add delta time to the lifetime. Then if the lifetime exceeds the maximum lifetime, which is another value we're going to keep track of, then we want to destroy bullets because we don't want an unlimited number of bullets out there in memory. Eventually run out of memory, so you need to either free those up or reuse those, set them back to active at a later time. An alternate way of calculating the X position of the projectile is by saying the X position to the original position plus the lifetimes times the velocity of the projectile. You also want to remember to have a cooldown delay whenever you're shooting, so when it doesn't allow the player to repeatedly press the shoot button, either the key press or the button, over and over again. You want to have a little bit of a delay in their cooldown period. So here's the first demo. I'll put all the code out in a source code repository. So basically, I have all the weapons implemented. And so special weapon 00 is the base, just platformer, no weapons at all. Then each other weapon, I have special weapon 01 through special weapons 10 for the implementations of each of the weapons. So here's 00 right here. Basically, it's just a 2D platformer. You can refer to my jumping talk that I did a while back for details on how jumping is implemented. But this also has the player and block collision as well added to it. So here's special weapon 01. So this is the buster normal weapon. I got some enemies instantiated there. So you can jump with Z, press space to shoot. One thing I don't have implemented in this demo is the destroying the projectile when it hits the enemy, but it does destroy the enemy or adds damage to the enemy as it collides with that enemy. So this is the contents right here. So basically we have the bullet right here and update method, and this is where we're adding velocity X times delta time to the X position. And then if we loop through all the enemies, if it collides with an enemy, then we're going to set damage to 1 to the enemy. So we have the enemy class over here. Enemy class right here. And basically the enemy has a health value, int, and is alive. Bool. And here's our set damage. So we're going to subtract off the damage value from the health. If the health is less than or equal to 0, we'll set is alive to false. Then in our update, if the enemy is not alive, we're just going to return. Just bail out of the update right there. Don't do anything. I'll also mention, so we have the base default game class here. So we got our player. blocks, list of bullets, list of enemies. This is where these are all getting instantiated right there. We also have a level reader. So basically we have in a text file the layout of the level, and the X's are the blocks and the E's are the enemies. So the next weapon I'll talk about is the 8-way shooting. You see this in a lot of classic platformer games. So if you hold up, then you're going to shoot upward. If you hold up and over, you'll shoot up into the over direction. So basically you want to get the horizontal and vertical axis input. Now this may be the up and down arrow keys or left and right arrow keys, or it might be your left thumbstick or a D-pad. Basically what I did is I added a weapons class, so each special weapon subclass is the weapons class with the weapon type. What you want to do is you want to normalize the X and Y vectors of direction the player's holding. We use the old Pythagorean theorem to get the magnitude, square root x squared plus y squared of the direction the player is pressing. They'll give you the magnitude of that vector, the way the player is pressing. And then basically you just divide the x component and y components by that magnitude to get the initial velocity and the normalized vector for that projectile. Then if you want to speed it up, you can multiply it by a speed variable, but this gives you the normalized vector the way the player is pressing. So this, you could extend this to actually a 360 degree shooting using the thumbstick. You also want to check if no direction is pressed, and the X velocity, just set it to the facing direction of the player, either X1 for facing to the right or X -1 if the player is facing to the left. Otherwise, if it has 0 magnitude, you'll probably get an error for dividing by 0, maybe. But it just won't move. The projectile won't move if you're not pressing in any of the directions. Some other games, alternatively, the player may crouch when they shoot, when they hold down and shoot. I won't be doing that in this example, but that's another option instead of shooting downward. So here's 8-way shooting right here. So if you just don't press any direction, you shoot either left or right, but you can hold up and over to shoot up and over. You can hold up to shoot upward. If I jump up to this platform over here and hold down, I'll shoot downward and then shoot down to the right like that, or up and over like that. And I can press tab to switch back to the old Buster weapon, which doesn't allow you to shoot up or down. So we can see here we have weapon 8-way. You can see we have a name property 8-way. That's what gets displayed. In the upper left-hand corner, we have the shoot delay max. You can see here, weapon 8-way extends the weapon class. Just beware down here, and here's where we're instantiating the bullet. Using the same bullet right now, this is where we're setting the X and Y velocity. So we're using game player input direction X, game player input direction Y. This should have that normalized. It may not have that currently implemented right here. So the next weapon I want to be talking about is the freeze weapon. So there's a couple of different ways to implement this, but either way you do it, you want to have a freeze status added to your enemy superclass. If you have different types of enemies and you want them all to be frozen, you just want to have one enemy superclass, then subclass those with the specific instance types, but you want to have your freeze status on the enemy superclass. So basically, whenever this freeze status is active, we're going to prevent the enemy from moving or attacking. We need to have a countdown that unfreezes the enemies after a set period of time. As I mentioned, you can either freeze all enemies at once, which is what I'll be doing in the demo, or you can only freeze enemies hit by a projectile. That's another way you'll see freezing done in games, and in that case you'll have a freeze timer for each enemy. One thing you want to do is alter the appearance of the enemies that are frozen, so you know that they're actually frozen. And in some games you'll see frozen enemies being used as stepping stones. I don't currently have that implemented. So here's the freeze weapon right here. You can press the space bar and that'll freeze the enemies for a set period of time. I think I currently have it set to 5 seconds. So you can actually press tab to switch weapons, so you can actually freeze the weapon or freeze the enemies all at once, then switch to another weapon to shoot them. So you can see here's the weapon freeze code right here. Basically, so whenever the player presses shoot, we're going to leap through all the enemies and call enemy start freeze. If we look at the enemy class, start freeze is down here. Set the freeze countdown to 5 seconds. Right here, freeze countdown. That's just an instance variable on the enemy class. Float freeze countdown. So here in our update, it says if get is frozen, then we're going to reduce the freeze countdown by delta time, subtract off delta time, and then we're going to return. We're not going to do anything else in update if the enemy's frozen. On our draw call, we call if is frozen, then we're going to set the color to light blue, and then we basically pass that light blue in as a parameter to the draw method for that sprite right there. And here's our get is frozen. So I don't keep a separate bool variable for is frozen. Basically, I just look at if freeze countdown is greater than 0, then we're going to return true, otherwise return false. So we don't have a separate variable for frozen. We just call this method right here. So the next weapon I want to talk about is the wave weapon, the wave beam. Basically, we're going to subclass the bullet with the bullet wave. I'm going to have the update method as a virtual override, and it's going to be an abstract method, and we're going to override in the subclass using the override keyword in C#. All the private instance variables in bullet, we need to change those to protected, such as like the X position and Y position, just so they're accessible in the subclass. We want to add X original and Y original properties to the bullet. So in this case, it's going to be like the second case of the Buster, where we keep track of the X position, X and Y original position, and set the position based as an offset using the lifetime and the speed. So here's the code right here. X gets their X original. So the X position is going to be the same thing as the busted alternative method. X original lifetimes times speed times X direction. X direction is just -1 or 1 based on the way the player is facing. 1 for facing right, -1 for facing left. So then we're going to add Y is the Y original position plus the sign of the lifetimes times 2 pi times the number of oscillations. So an oscillation is going up and down and back up. That's one like oscillation right there. So if you want 2, you just increase that oscillations value. Then you can set this wave height right here to set how high you want it to be. So if you only want it 1 block, then you just set it to 1 times the block size. If you want it 2 block sizes, like way up and down from the starting position. So it's going to actually go for total from top to bottom if you set it to 2 block size. Or if you only want it half, then you can set that right there. So here's the wave weapon right here. So yeah, basically goes in a sine wave. I think that we have the oscillation set to 2. So it definitely goes through the blocks and everything. So if we look at the code, here's our weapon wave right here. When you press shoot, we're going to set the bullet direction, P, X facing. And we're going to instantiate the bullet. So we're going to have a special bullet wave subclass of bullet. And then we're going to add that to the bullets list. So if we look at bullet wave, we can see public class bullet wave, subclass is bullet. I'm going to set the X position and Y position. We're also going to keep track of the lifetime there. So here's where we're calculating the X and Y. So X gets X original position plus lifetimes times speed times the direction the player's facing. Then the Y is going to be the Y original position plus math sine of the lifetime times 2 math 2 pi times. So we wouldn't go up and down 2 blocks, 2f. Then we wanted to go outward. We want the height to be block size times 2. So we multiply by that right there. So the frequency goes within the sign called, then the height goes outside. So I think what's cool is, like, if you know how to do a wave weapon, you can also do a boomerang weapon. So there's a couple of different ways you can implement a boomerang. In some games you may see it where the boomerang goes like straight out and then it tracks back to the player's position, the player's current position. I'm not going to be doing that. This boomerang is going to go out in a circular pattern and return to the original position. So it'll return to the player if the player hasn't moved, but if the player has moved, then it'll just return to that original position where that bullet was shot. So the neat thing is, it's very similar. You wouldn't think about it, but the boomerang is very similar to the wave weapon. All you have to do is add the cosine component to the X position to make it move in a circular path. So basically, we're just going to go around in a circle. But you can do some things like X gets X original position plus cosine, lifetimes times 2 pi, times the distance, times negative facing, plus the different offset. What we want to do is limit the oscillations to 1, so it only goes around once. Otherwise, it'll keep going around in circles. We'll return to the starting position. Yeah, so let's take a look at that. Yeah, so here's the boomerang weapon right here. You can either shoot it to the left or to the right, and you can see basically just goes kind of like an ellipse and returns to the player's position. So yeah, it's just basically an ellipse, a circular pattern that's going through right there. So if we look at the code for weapon boomerang, going to shoot, and we're going to instantiate a bullet boomerang, set the X and Y position, set the direction that it's going to move in. So the bullet boomerang is going to extend bullet. You can see here we're going to set the distance to 4. It's going to be 4 blocks for the distance. The vel X is going to either be 1 or -1, just a way that it's going to, if it's either going to go in positive X direction or negative X direction. So here's where so Y basically stays the same. Y gets Y original plus the sine of lifetime times 2 pi times the block size times 2f, the height, amplitude. But then we're just going to add X gets to X original position plus the cosine of lifetimes times 2 pi times the block size times the distance. So that's 4. So we're going to have it go up 2 and out 4. And then make sure it's going in the right direction. And then we're going to add an offset just to make sure that that starts and stops where the player is set. So that's what we're setting up here, is this offset. I'll also mention in the game class, this is where we're keeping our running list of weapons. So we got a list of weapons. So we got like our buster, our 8-way, or freeze, weapon wave, weapon boomerang. So you can see as I press tab, it changes which weapon you have. Like there's the 8-way, and here's the freeze, and here's the wave, and here's the boomerang. So you can easily switch between those. And if we were making this into like a real game, you may have like limits on how many times those weapons can be used, or cooldown, things like that. So the next weapon I'm going to talk about is a tornado weapon. So we're going to instantiate 3 bullets at the same time. They're all going to have a constant X velocity, but they're going to have different X velocities. So like the first one's going to be 2 units per second, the second one's going to be 4, and then the final one's going to be 6. So it's constant x velocity, just different x velocities. The y velocity is going to start at 0, and it's going to gradually increase by constant acceleration. So they're all going to rise at the same time, but then they're all going to have different x velocities, so they're going to spread out a little bit. So an example acceleration is 40 units per second squared. So here's the tornado weapon right here. So you can see it kind of spreads out, kind of like bubbles, I guess. It's good for hitting these enemies that are up high on platforms higher than you. So I mentioned earlier, there's no collision between the bullets and the blocks. They just kind of keep going. So if we look at our weapon tornado right here, when we press shoot, here's our bullet tornado. So we're going to instantiate 3 of these. Here's where we're setting the x velocity. So the first one's going to be block size times 2. The second one's going to be block size times 4. The third one's going to be block size times 6. Then we're going to set the initial y velocity all to 0 for all 3. Then we're going to add all of those to the list of bullets in the game. If we look at the bullet tornado, you can see it extends bullet. And see update. We got the y velocity. We're going to add the y accelerations times delta time. So the x position is going to get the x original position plus lifetimes times velocity of x. Y position is going to be the original y position plus lifetimes times velocity y. So the next weapon I want to talk about is a charge weapon. So to do this, I've implemented adjustable enemy health. So each enemy has a different health value, initial health value. Got to ensure that the bullet is destroyed after the enemy collision. Otherwise, you can have a bullet projectile with 1 damage that will continually collide with an enemy. So it really needs to be destroyed or set inactive after it's collided with an enemy. So the charge is a little bit different. All the other weapons have the shoot method has been called when the player presses down on the button or down on the space bar. This one is going to shoot when the user releases the key or button. That way, you know how long it's been charged. So we're going to subclass bullet with adjustable damage. We're going to subtract that amount of damage from the enemy health on collision. We can set a countdown for determining the amount of charge and amount of time to charge between the different levels. We got charge and release charge methods on the player to calculate the charge time, to add up the charge time. We also have a visual to show the current charge level. In my demo, I just have it displayed as a number. So we also want to check that the weapon type is a charge weapon, using the class comparison to add the charge time and determine when it's been released. So it's a little bit different than the regular shoot method. So then we're going to have a release charge method, and it will determine the charge level based on charge time. So we're going to set the charge level when it's instantiated. We're going to change the bullet appearance. We're going to change the bullet size. And then after the charge has been released, we're going to check the weapon charge time back to 0. Okay, so here's the charge weapon. As you see here, I have like a green enemy that has 1 health, the blue has 2, and I think red has 4 or 5, maybe 5. So you can see up here, I got the weapon charge 0. As I hold the charge button, it'll go 1 to 2. Then when I release it at 2, you'll see that the big red charge, particle charge right there. If I just press it briefly and release, it'll just be green. So that only does 1 damage. So if I jump up here and do 2 quick greens, it takes 2 to defeat that enemy. If I hold it to like 1, it'll be the bigger blue. So that took 2 to defeat that enemy. And then if I like hold it for 2 seconds, so the charge is 2, and then I can shoot that guy right there, and that'll automatically take him out. So yeah, if this was a real game, you'd probably want to have like little sparkles and stuff as the player's charging or flashing. Something a little bit better for the charge level. But you'll also notice as the for the higher charge levels, the projectile is larger. So in our player class, we now have a charge method. And basically it's checking, here's what I'm doing the class comparison. If the weapon is a weapon charge, we're going to call weapon.charge. Then we have charge release. If weapon is weapon charge, then we're going to call release charge. So if we look at the weapon charge, again, subclass is weapon, but it has a charge time that we're tracking. So if we look down here, here's our charge method that we're implementing. Charge, add and assign, time. Time's basically just delta time right there. Here's charge release. This is kind of like the shoot. Got the X and Y position, direction, same as the buster. But we got a bullet charge here. Bullet charge gets a new bullet charge, set the X and Y position. So here's where we're determining what the charge level is. So if the charge time is less than 1 second, then we're going to set the power to 0. If the charge time is less than 2, we're going to set the power to 1. If the charge, otherwise, it's been held more than 2 seconds, so we're going to set the power to 2. So if we look at the bullet charge right here, the bullet charge has a power int on it. Here's where we're setting power, passing the value, the power gets that value. Then we're setting the size based on the power value right here. Then in the update method, it's basically the same as the buster as far as the path. So then we're going to check collision with the enemies. If the power is 0, then it does 1 damage. If the power is 1, it does 2 damage. If the power is 2, then it does 5 damage. So you got to do like a switch statement right there to like map the power level to the damage amount. Then we're going to call E set damage to that damage value. Yeah, so that's basically, oh, and also in our draw method, we use a similar switch statement to set the color. So if it's power 0, then it's going to be green. If it's power 1, it's going to be blue. Then power 3 or 2, it's going to be red. And then we just paste that, use that color variable down here to set the color of the projectile. So the next weapon is the orbit or shield weapon. It's kind of neat. So basically, we set the orbit position. We're going to instantiate 4 projectiles, and the offset in radians is going to be 0, pi over 2, pi, 3/4 or 3/2 pi radians. So in degrees, which we're not doing, that would be 0, 90, 180, and 270. The way I implement this is by setting the initial lifetime, which is the percent around the circle that the projectiles should go, the current position in percent divided by the speed. A couple of different options with this weapon you can have. The orbit shield track with the player, which is what I do in the demo. But the orbit weapon needs to keep a reference to all the bullets associated to it, so it can update the bullet orbit position as the player moves. Or you'd have it where if the player moves, then it kind of just like shoots off the projectiles, or in some way. They can either go outward or forward or up, or what you want to do. So the orbit bullet, we want to track both the speed and the lifetime, and there's no max lifetime on these bullets because they're just going to keep orbiting. Okay, so here's the orbit shield right here. So we press space, and you can see those projectiles are spinning around me, and then when they collide with an enemy, then they get destroyed like that. And then I can press space again to like instantiate new ones. Like I said, you could have it where if you like press the space bar, shoot again, then they shoot off to the side, or whatever you want to do. Or you could have it where they shoot off to the side as the player moves. You can handle it a few different ways right there. But I think it is just pretty cool how you can have it. I've seen other games like do this where like you can have a power up, a shield or whatever, and it just never goes away, or however you want to handle it like that. And you can have more projectiles. You can have 8, you can have 3, you can have 2, whatever you want to do. It's pretty cool. Or you can have it variable, something like that. But just did 4 for the demo. So here's our weapon orbit. So here's our shoot method. We're going to clear out we can keep a list of bullets associated to the orbit weapon, destroy those if there's any that exist. We're going to get the X and Y position right here, player X, player width divided by 2. So it's going to orbit around the center of the player. So that's what's doing right here. So the bullet Y position is going to be player Y position plus the player height divided by 2. So here's where we're instantiating the 4 bullets right here. Bullet gets a new bullet orbit, X and Y. We got this set offset, got it set to 0 for the first one, 0.25 for the second one, 0.5 for the third one, and 0.75 for the fourth one. Want to add that to the list of bullets for the game, but then we also want to add it to the list of bullets for the weapon, because when the weapon is updated, we're going to set the orbit position, the position that's rotating around, to the current position of the player right there. So we do that on every update. If we look at bullet orbit, subclasses bullet, we're going to set the distance, how far out it's going to orbit around the player, the orbit speed. We have it 1 orbit per second, but you can't change that to make it go faster or slower. Here's where we're setting the position. X is X original, kind of like all the other ones. Original X position plus cosine of lifetimes times 2 pi times the speed times the distance. And the Y position is the Y original position plus the sine of lifetimes times 2 pi times the speed times distance. Then there's checking enemy collision. So here's where we're setting the offset right here. That's at 0, 0.255, and 0.75. So basically we're setting an initial lifetime to percent over speed. So that's what makes them spread out. If you didn't set this, then all 4 bullets would be at the same position, orbiting on top of each other, which doesn't look good. And then we have set orbit position right there where we set the original X. So this is really used for when the player is moving, so it orbits around the player. So the next weapon I'm going to talk about is what I call the roller, or the bubble, whatever you want to call it. So it has a constant X velocity. So what's interesting about the roller is it's very similar to the player. So it uses gravity. So you apply gravity similar to the player, and it also uses like the grounded state, similar to the player in falling state. So I actually reused some of the player falling code to implement the roller right here. You wanted a story on horizontal wall collision. I don't think I implemented that. No maximum lifetime. So here's our roll state, grounded and falling. And so what I did is I added an initial Y velocity to the roller. So it kind of goes up a little bit in Y, in the positive Y direction, but it has a constant as it's falling, as it's not going up, then we're going to subtract off the acceleration value from that. So it's going to give it an arc whenever you shoot it. So a falling, check collision with blocks on update, transition to grounded on downward collision. So here's the roller right there. So it's going to go away as it collides, but you'll see right here as it goes off the platform. So let's jump up here at the very top, shoot it from here, so you can see kind of just like slides, kind of like ice or a barrel or something like that. And you see that little bit of an initial Y velocity like that. And you can see it kind of like shoot up at the end. That's because I didn't do the X collision. X wall collision. So really the roller should be destroyed when it has the X collision. I just didn't get to that. Let's look at the weapon roller. I think this is pretty similar to all the other ones, except we're doing a bullet roller right here on the shoot method. And we'll add that to the list of bullets. So it's really all in the bullet roller class. So the bullet roller, as all the other ones do, subclass is bullet. We got our enum roll state, grounded or falling. We got our fall acceleration, block size over 2. We got our roll state, instance variable right here. Here's our speed. I'm going to set it to block size times 8. There's our initial Y velocity is 8 times the block size. Initial roll state is falling. It's quote unquote falling. If it's not going up, then it's falling, kind of like with the player. If you're not jumping, you're falling, but you may still have an upward trajectory and still be falling. So here's our roll state. If it's falling, then we're going to add the negative fall acceleration to the Y value. Then we're going to add velocity Y times delta time to the Y value. If it's grounded, we want to check to see if it's still grounded. So we do a check collision with 1 pixel below to see if there's anything below it. If there's nothing below it, if it's rolled off a ledge, then we're going to set the roll state to roll state falling, so it starts falling again. And yeah, so basically roll state, check collision with the blocks. If it's falling and it's collided, then here's where it says it's grounded, and then we're going to like push it back up so it's level with the ground. So yeah, that's a pretty easy weapon to implement right there, the roller. And the last weapon is the exploder. So the exploder is going to have 3 states. The first state's moving, similar to the buster. The normal weapon is going to move at a constant X velocity, 0 Y velocity. When it collides with the block, it's going to transition to a wait state when it collides with a block or a wall. And the wait state, the wait countdown begins, no damage. Then it's going to explode after that countdown expires. And then it's going to increase the hitbox size. You can do a different sprite. I just make it bigger. I don't change the sprite. Enable the damage, and it can hit multiple enemies as well. And it can destroy blocks on explosion as well. And that's something in my demo right here. It destroys all blocks, which could leave your game in an unstable state where the player may not be able to finish the level because you made a gap too big to cross. So I've seen this implemented in other games where there's only special types of blocks, like on an exploder weapon, that can be destroyed. So that's one way to handle it, like subclass or block class, and only allow certain blocks to be destroyed on explosion. So yeah, you can see here I'm shooting, and then it turns red when it's collided, then it explodes. If it hits an enemy, then it just damages the enemy and does not explode. You could have it like explode on damage with an enemy too. I just didn't implement that. But you can see right here, you can like stick these guys on all the walls and really start to mess up the level right here. But yeah, it is kind of hard. Like right there, I could have like had it explode and hit the enemy as well. But yeah, I've seen this done in other games. Like you can have it make a shortcut or something when you blow up the blocks. Whoops. So yeah, that's like one of those unstable states where you can like destroy the ground and fall through the bottom of the world. So you gotta pay attention to that. Take consideration of that. So weapon, exploder, I think this is similar to all the other ones, except we're doing a bullet exploder, X and Y position, like all the other ones. Bullet exploder, here's where all the logic takes place. So here's our wait countdown max. So when it hits a block, it's going to wait 2 seconds. Explode countdown, once it's exploded, it's going to stay exploded for 0.5 seconds. We got our state. It's either moving, waiting, or exploding. Here's our state instance variable. We're going to set, I think the original state is moving. Going to set the speed, block size times 16. So yeah, maybe I should put state equals moving in the constructor right there. I didn't explicitly put it, but I guess since it's the first one, 0, then it automatically assumes the state moving. So I could have did this in a switch case, but I just have the state moving. Then we're going to check collision with any of the blocks. If it has collided, if that returns a non-null value, if it's collided with a block, then we're going to set the countdown to wait countdown max, set the state to wait, then get out of that. Otherwise, we're going to move it in the X direction and check for collisions with the enemy. If the state is waiting, it's collided with a block, and it's just waiting to explode, we're going to subtract delta time from the countdown time. If the countdown is less than or equal to 0, we're going to set the countdown to explode countdown max. So we're starting exploding now. We're going to increase the size of the hitbox by 2 block sizes. And then we're going to like offset the X and Y position. Then we're going to set the state to state explode. So then in explosion state, we're going to subtract delta time off the countdown. If the countdown's less than or equal to 0, we're going to destroy it. Otherwise, we're going to check collision with the enemies, if it's collided with any enemies. And here's the block part. For all the blocks, we're going to get all the blocks. If the explosion has collided with any of the blocks, then this get collided block is going to return a list of all the blocks the collision has collided with. And then we're just going to go through those blocks and remove those blocks from the game block list. That's basically, and here's where we set it to red. The state, if it's moving, it's going to be white. If it's waiting, it's red. If it's exploding, it's red. That's where I said you can have different sprites for the different states. Yeah, so that's basically it for this month's Knox game design. Yeah, it's something I kind of always wanted to do, just like an overview of different types of platformer weapons and how to implement those. Like I said, I'll put all the code out there if anybody wants to take a look at it and see how I implemented those. I'm not saying my method is the best method or anything, but it's the way I went about implementing these. So hopefully everybody found it useful and interesting, and I appreciate everyone out there listening and watching, and I'll plan on being back in a month.